XDF, and we're doing Advent of Code 2024, Day 21, Keypad Conundrum. This one is the first one of the year that I found really, really hard. I've been working on this for a few hours. I don't have a video of me solving the whole thing. I'm short on time for the holidays, and we're just going to go over my solution. So hopefully that's all right. I wanted to get something out there. So the challenge is going to be, we have this keypad, and we have a robot that we have given instructions to. So we can say, like, the arm is going to start over the A, and we can say, like, go up and then push, and that'll push a 3. And we can say go up, up, push, and that'll give us a 9. And we can say, like, left, down, push, and that'll give us a 5. And so it turns out, actually, though, we don't have control over this robot. We have control over the robot that has control over this robot. And so that robot is on this command. So for this one, we would say, like, if we wanted to tell him to move to push a 3, we would have to say move left, push, move right, push. So we'd go tell it to move up, and then we'd tell it to push. In fact, we don't have control over this robot. We have control over the robot that has control over the robot that has control over the robot. And so you can see how this can get very complicated very quickly. The other thing to note is that there's multiple, well, so like if I wanted to go from A to 3, there's only one shortest path. But if I want to go from A to 2, there's 2 shortest paths. I can go left, up, or I can go up, left. To get to 8 to 5, I can go up, up, left, up, or left, up, up. And so, they give us this example here for how, just on the number pad, you would push 029A, and you'd move left A, right, up, A, but you could also go up, A, or up, right, A, and then down, A. And that actually generates these 3 different possible paths that are all the most efficient. And because of the way we're propagating this up through these different robots, we kind of have to keep track of all of those. So our challenge is to take each of the inputs and calculate the shortest path possible that we can push to get that sequence, and then multiply it by, we can drop the A and just turn it into an integer and multiply by that. And then we're going to sum all those up and get our result. Okay, so the first thing I did here was I put in the number pad and the dir pad as dictionaries. And this just allows me to not worry about balance checking or whatever. I can just loop over these coordinates and get positions or get the values. I found it easier to work with it this way. Then what I'm going to do here is I'm going to create some one time, just right at the beginning, I'm going to create this thing I've called numpad paths and dirpad paths. And that takes in position, start and an end. And it says, give me all the paths from that start to that end that are the shortest path that fit that length. In fact, we can, we comment out, we don't even need lines. We do part1 equals numpad paths, add paths. And we run this, day 21, part1, text. You can see right here, so to get to, so to get from A to A, you just push A, but to get from, let's find out something that has actually some value in it. Go from 0 to 3, you can go up, right, A, or you can go right, up, A. And so that gives us all the shortest path. So by having that, to do that, I need to have this function to do that. That's going to take in the pad, the 2 points, and I'm really just going to loop over all possibilities of points. Okay, so what is my function? Okay, well, if the 2 points are the same, to get from 1 to 1, great. Just push A, you're good. Otherwise, I'm going to do a flood fill. And basically, it's kind of like a breadth first search. We're going to create a queue. This best length is very arbitrary. It's just like there's no path on this. I could probably do 10, honestly, it'd be fine. But there's no path on this thing longer than 100. Because we're not just going to get to the first shortest path and stop. We need all the shortest paths. So we'll keep a list of the paths. We'll start with our state, which is our position, as well as the steps we've taken so far. And so for next move, we can go down, which is increasing the row by 1, and then we store the next move will be down, or we can go up, or we can go left or right, and if the next position is not in the keypad, well, then I'm done. I don't keep going. Don't worry about that. If the next position is the target position, but the length is too long, well, then I'm just done. Return optimal path. If the next position is the target position and the length is not too long, because if it was, I would have already returned. In fact, I don't even know if I need, I'm going to check in a second. I don't know if we even need this, but we'll come back. Might make it a little faster. If we've gotten there, we will update the paths. We'll add this path, which will be the path so far plus the current move, plus we're going to need an A on the end, because we always need an A to push. And then we'll update our best length to be that length of path plus 2. And if it's not y, then we're going to just append the next path, the next step into our queue and keep going. Let's see. So if I do Python example, we're going to, Python data example.10. Oh, I didn't want, am I still, we're going to skip ahead a little here. I'm kind of curious to see. Get rid of view. That was just for some debugging. We run this, we get example. It takes a second, you'll see. But so 126,384 is the correct answer. I think we can get rid of this and just say if the length is too long, we're done. But I don't know if that's true. Let's see. It is. It didn't seem to make it any faster, but basically if we get to anything, because the way breadth first search works, we're going to do all the lengths 1, then all the lengths 2, then all the lengths 3. So if we get longer than the length, we can stop. Okay. Now we've got these maps that I give it a start and an end, and it tells me all the paths I can take to get there. Cool. So what do I do? This is not turn out to be a very efficient solution, as you saw, but so we're going to say for each line, for each code, we're going to set our best length to infinity. I set it something lower, but I didn't know it was lower. We will say for each path we can get out of numpad paths for some code. So keys to path. Let's say all I'm doing for keys to path is basically saying, I'm going to get the keypad paths for that. I'm going to take all the steps. So the code, I'm always starting at A. So to go from A to the first item, basically I'm doing this zip trick where you take, if you have two lists that are offset, like this one's going to be one longer than this one, I'll have A with the first item of here, the first item of here with the second item of here, third to fourth, fourth to fifth, etc. until I get to the end of code and then I stop. And so there's a way of saying basically, give me all the steps I need to take because I always start at A. And so then I can put those together and I can get the paths for each one of those. And then the product of those paths will be all the different options that can come out of it. So in my example, the paths will be, I will have left, so it'll be like left A, up A, and then this one will have 3 different options, and then this one will have 1 option. And by taking the product, I will get these 3 different things out. So I get back all those, and then that's my path. Those are my 3 paths. So I'm gonna loop over those, and then I'm gonna do the same thing with the dir paths, getting all the pathsable paths for each of those, and the same here. And I'm just gonna keep track of the best length. And once I am done with all those, I will multiply the integer value of the code times that best length to get part 1. This is not super efficient, but it solves. And it doesn't work in part 2, so we basically have to start over. It takes, to run on the actual input takes a fair amount of time. Okay. So part 2, the problem, part 2 challenge. Let's go back to that. Let's try to keep roughly the same format. It turns out there's not 2 robots in the middle, but there's 25 robots in the middle. So clearly I can't, if I try to even just make this, if I even try to make this a third one, it goes forever. So that's not going to work. So we have to figure out something else. I'm going to do something. So basically converted this. First thing I did was say, okay, let's convert this and solve part 1 where we have kind of a get length with, we pass part 2 in there, pass 2, and then we can just do the same function with 25. And basically then my loop can stay the same here. I'm just going to keep 2 different best lengths, and the solutions are the same, and there we go. So what are we going to do to get this? I need this get length function. I'm going to do the same. I'm going to ignore, basically I don't want to change. I think I could update this all to include the numpads as well. But since I already had the solution working, and that part on its own doesn't feel that slow, I'm just going to loop over the paths coming out of the numpad. So now I'm just dealing with the directional keyboard. I don't have to worry about the number of head keyboard. So when I write my get length function. So get length is going to take a path that needs to happen, and it's going to, and a number of robots in the middle, and it's going to return a length. And then I can compare that with the length, the best length, and keep the best length. What does this look like? And what makes it work? It's not very long, actually. Once I figured it out, it was actually kind of elegant. But so if the depth is 0, if there's no robots left, I'm just going to return the length of the code. That's the length. Length is the length of the code. So I've got my recursive step. If otherwise, I'm going to say length equals 0, and I'm going to I'm going to do my same walk here that I did up here. To walk over on line 40, I'm walking over all the moves. And so for each move, the thing that we need to think about is the moves are independent of each other. It doesn't matter how I got, if I'm doing 0 to 9a, the best way to get to 2 doesn't have no impact on the best way to get to 9, regardless of how many robots are there. So instead of trying to keep, when I was doing this kind of search, I'm having to keep every possible path in memory at the same time. Versus now, I'm going to do a recursive search where I basically just say, get the length for each sequence. So here, get the length for each sequence in the possible things, and take the smallest one, add it together. So for each step I need to make, just get the shortest way to do it and be done. And then return that length. And so this recursive thing of just getting one less step will just help me get there. And now I can cache it. And that's where it really shines. If I don't cache this, if I comment that out and try to run it, it doesn't. Oops, let's see. I didn't. I guess I can show you this works. But without caching, this hangs. This runs for a long time. Let's just kill it. You can trust me on that. But as soon as I cache it, now I'm going to get the same code and depth. It's going to happen a lot. And now when I run this, it's like instant. And you can see I get the same number, 157,230, that I was getting before. Where was that? 157,230. And instantly I get this giant number that is my part 2 solution. I can't believe how short this actually turned out. I think, so what I was saying is, I think I can probably, so this right here, pre-compute all the paths, that's fine. I think this right here, I could probably work into my recursive function. Basically what I would do, I would say, instead of if depth equals 0, instead of doing that, I would then be first or last. Yeah, I would then do this stuff right here to figure that out. I just don't have time right today to mess with it. So exercise for the reader. Go play with this. I mean, because you didn't get to watch me kind of experiment and fumble through this for hours. If any of this is not clear, I recommend just, I mean, first you should try it on your own. But if you're stuck and like they have no idea how to go forward, like download my code and mess with it and debug it and step through it. Put print statements in and see what happens. And this was a cool problem. It was very hard. So I'll probably, well, I don't know. I'm going to be kind of busy for the holidays for the next few days. So I will make some videos for the remaining 22, 23, 24, 24 4 challenges, but I can't promise they're going to come on the right days. So I will do my best to get something up, but yeah, thanks for hanging out with me today, and I will talk to you sometime soon. Bye.